For the Modelling with Algorithms course, you need to know how to execute the quick sort algorithm. So I thought I would do a couple of examples of executing this one. So this question says to use the quick sort algorithm to sort these numbers, we've got 12 numbers here, into descending order. Okay, so for the quick sort algorithm, we are going to select the first entry into in the list, and then subsequently in later iterations we will do the first entry for each sublist, and then we work down the list, and any number that is bigger than 142 will go to the left of it, and then any number that is smaller than 142 will go to the right. It's important that the rest of the numbers remain in their respective orders though. So comparing everything to 142, 144 is bigger, so therefore will go on the left. 175 is bigger. 171 is bigger. 182 is bigger. 146 is bigger. 131 is smaller, so I'm going to leave that one out. 188 is bigger. That's smaller. This one's bigger. 194. 136 is smaller, and 178 is bigger. So those are all the numbers that are bigger than 142. Then in goes my pivot. Okay, and now I've got to box that one because that is in place. And then the other three numbers which I missed out will now appear on the right side of them. It's got 131, 114. And 136. Notice that those numbers appear in the same order that they appeared in the list. Okay, that's important as part of the algorithm. Okay, now we repeat that exact process on each of the sublists. The 142 is now locked in place. I've represented that as a rectangular box as opposed to a circular box. Circular box will represent an active pivot, and a rectangular box will represent one that has been a pivot but is now locked in, so it's not going to move again. Okay, so for the left-hand list, this one is going to be the pivot because that is the first number in that list. And then for the right-hand list, this one will be the pivot. So I'm going to circle both of those. And then I shall apply the quicksort algorithm to each of those sublists. So 144, that is quite close to 142, so I don't think there's anything in between them. Nope. So 144 will go here. That is now locked in place. I'm going to pop a rectangular box around it. 142 is already locked in place, and then 131 is actually in the middle of those two. 136 will go there, and 114 will go there. At the moment we just leave those not circled. All of these numbers will then appear in the same order here. So 175, 171, 182, 146, 188, 194, and 178. What's really happened here is all of these numbers have been compared to 144. They've all come out to be bigger, so they all go on the left, and none of them are smaller, so nothing goes to the right. Nothing is in between the 144 and the 142. Okay, now we've got three sublists. We've got this list, but these two sublists are a length of 1. So they are already in place, so we don't have to do anything with those. So 144 will go here, pop a rectangle around that. 142 is there. 136, that's now locked in place. That technically was a pivot that was chosen. It's just the sublist is length 1. 131 has been locked in place, and similarly the 114 is locked in place. And now it's just this list to deal with. 175 is the first entry, so that is the pivot for this one. Okay, so 171 is smaller, 182 is bigger, so that's going to go here. Smaller, bigger, 188, 194, and 178. Okay, so those are the four numbers out of these 6 which are bigger than 175. 175 is now locked in place, that will go there in the list, and then the other two numbers that we missed out earlier, so 171 and 182. Okay, so all of those locked in place. We've got two sublists now, a length of 4 and a length of 2. This is going to be the pivot for that sublist, and this is going to be the pivot for that sublist. So those two are bigger and that one is smaller. So we're going to get 188194. Don't forget to keep it in the same order that it is in the list. 182, that gets boxed. 178 will go there. 175 was already boxed. 182 is bigger. Oh, what have I done wrong? Ah, that shouldn't be. That should be a 146. Ah, there we go. Made a mistake there. I'll correct that in a red pen. That should be 146 there. Apologies. 182, 188, 194, 178. Yeah. 171, 146, yeah. Okay, so that should be 146. Okay, so 171 and 146. 146 is compared to the pivot, which is 171. The pivot is bigger in this case, so it's going to sit on the left. 146 will go there. 144 is boxed. 142, 136, 131, and 114. And they all get boxed because they are already all locked in. Okay, we've now got 3 sublists, but this will finish the algorithm now. So this is the pivot, this is a pivot, and this is a pivot. So we're going to get 194, then 188 is boxed, 182 is boxed, 178 is boxed, 175 is boxed, 171 is boxed. That was a sublist of 1, so that's now just boxed. 144 is boxed. 142, 136, 131, and 114. They are all boxed. Everything is either boxed or a sublist of 1, so the algorithm stops. And that is now a sorted list. Okay, so that's the quick sort. And it's not a quick sort because humans can do it quickly. It's a quick sort because it's got a good order of complexity for it, so computers can execute it a little bit quicker than, say, bubble sort or shuttle sort or things like that. One more shorter example, because they can be sorted into ascending order. This is obviously descending order. So for descending order, we put all the bigger numbers on the left of the pivot and the smaller numbers on the right. But you might be asked for an ascending order question, in which case it's the smaller numbers that go on the left of the pivot and the bigger numbers will go to the right each time. It just makes sure that the list ends up in the order that you want it. So for this one here, the 25 will be the pivot because that is the first number in the list. And then any smaller numbers this time will go on the left because we are looking to sort the numbers into ascending order. So 21 is smaller, 22 is smaller, 32 is not, 47 is not, and in fact there's only 2 that are smaller. Then 50 is bigger, 49 is bigger, 32 is bigger, 47 is bigger, and 31 is bigger. Notice again that these numbers are in the same order that they appeared in the list above. They're just either side of our pivot point. So this is now in place. We're now going to repeat the process on each of these sublists. So 21 gets locked in place. 22 is now a list of size 1. 25 was already boxed. 50 is the biggest number, so 49, 32, 47, and 31 will all go there, and then 50 gets boxed at the end. Okay, so this technically would get a circle on it. This one is now the pivot, that's the first number in the list. So 21, 22 is now boxed, 25 is now boxed, 32, 47, 31, 49 is now boxed, and 50 was boxed before. And now we're down to a sublist of size 3. So this one gets chosen because that's the first in that sublist. And then the 31 will get put to the left of that. The 32 will get boxed in the middle, and then 47 goes there. 49 is boxed, 50 is boxed, and these 3 were already boxed, so 21, 22, and 25. That is now a sorted list because everything is either boxed or in a sublist of 1, size 1. Okay, so that completes the quick sort algorithm. That is one you need to know how to execute. A question could say that with a list of numbers, and you'd have to show the algorithm being executed correctly. Don't forget that a circle is an active pivot and a rectangle is a locked number. Okay, that is one that is already in its correct position in the list. Okay, thanks for watching, and check out the next video and anything else you need help with.